Hi, I'm Philippe Bergeron, Product Manager at Nokia, working on the IP routing platform.
Hi, I'm Stefan Meinders, Product Manager at Nokia Deepfield. I'm going to give you a brief introduction today about the Deepfield security solution, and Philippe is going to provide you a demo. Okay, let's look at the evolution of DDoS attacks and what has happened in the DDoS industry. I guess there is a lot of consensus around the industry. Attacks are growing from year to year, and we see larger and larger attacks. We have highlighted here some things that those attacks have in common, right? The characteristics of those attacks. Most of these attacks are coming actually from non-spoofed sources these days, and most attacks are coming from IoT devices. The important thing about the commonalities around these attacks is that all these attacks come from direct sources. That means we can mitigate the attacks based on source addresses, for example. Another thing that we see for recent attacks is that these attacks are actually a risk for the service provider networks from different angles of the network, different edges in this network. On the left-hand side, we see attacks coming in on their peering edge into peering routers. We see attacks on the top here, which are known as east-west attacks from one data center to another data center using hijacked servers, for example. We have outbound attacks from that ISP perspective, where hijacked or botnet IoT devices attack some destinations outside of that ISP, but that generates some huge traffic, of course, on the infrastructure of that service provider. In addition, we have targeted attacks still against business customers, so we need to actually protect the SLAs that the ISP has with the protected business customers and maintain these SLAs. And we have more outbound attacks, more inbound attacks. We have attacks that actually overload scrubbing centers because these attacks today are much larger than the scrubbing centers can handle. So the solution, Deepfield and in combination with FP4 provides is to enable the ISP to create protection around their entire network from every angle, from every edge of the network. Like in this slide, we have protection on the access edge, where we have this little network firewall symbols here in green, which do access edge protection. We can do peering edge protection, for example, to place firewalls, to place groups of security policies on the peering edge. And of course, we can protect the scrubbing center edge, the scrubbing center data center from large volumetric attacks. So the idea is to provide a holistic protection from attacks that can enter the network at every angle. To get more into details how this solution works, I'm focusing on the left-hand side, the Nokia Deepfield side, where we receive telemetry data from the network, from routers, that go into our Defender solution. Defender actually creates a new incident as soon as it identifies that there's a network anomaly. Existing already and used by all ISPs is the fact that we can do diversions then to scrubbers, we can do destination and source-based remote triggered blackholing and flowspec. But those are actually not granular enough, and those don't really solve the problem at the network edge. What we created is something we call network firewall feature sets. So a feature set is use case driven, what you can do at the edge of the network you are going to protect. You can, for example, install whitelists. That means all traffic that's coming from good and trusted sources is just whitelisted and forwarded to the destination and no longer diverted to the scrubbing center. So that reduces, if the network is under attack, the load on the scrubbing center. The same applies to our mitigation feature set. The mitigation feature set just blocks attacks directly at the network edge and therefore offloads traffic volume from the scrubbing center as well. The good news is that all of this can work in combination with the scrubbing center. So after our protections have been processed, the remaining part is still forwarded to scrubbing centers for further deeper analytics to identify application-based attacks and so on. The main piece to identify what's good and bad traffic is driven by our security and network intelligence feeds. We actually have two flavors of this feed, or in this feed. There is the Cloud Genome feed and the Secure Genome feed. The Cloud Genome feed is mainly used to identify the good traffic sources. So do I know where does this traffic originate from? Does it come from a CDN? Does it come from a known site in a CDN? And the Secure Genome part is mainly used to drive blacklists. So the Secure Genome knows all open DNS resolvers, it knows NTP reflectors, and so on. So using this intelligence easily allows us to create large CIDR lists and then do actions based on where this CIDR list is used. So if I use a CIDR list for whitelisting, then that traffic is forwarded. If I use a CIDR list for mitigation, that traffic can be either completely blocked or rate limited. There is one additional thing on the left-hand side here, which is our packet inspection analytics and forensics feature. You can create or instruct the router at every angle of the network to send you a copy of that suspicious traffic. So you can define which traffic you want to have mirrored into the Deepfield solution for further analytics or for forensic purposes. And now we'll hand over to Philippe for further details on the FP4 solution.
The FP4 is a Nokia latest network silicon, and it has the unique capability to mitigate volumetric DDoS attack inline in the network processor. To do this, we combine massive ACL scale inline in the FP4 with the ability to filter DDoS attack based on the signature found within the data payload, as well as real-time telemetry data, which enables Nokia Deepfield, which is our analytic platform, to identify the attack and program the filtering rule into the router. So what do we mean by filtering traffic based on a data payload? So if you look at a traditional IP router, traffic can be filtered based on layer 3 or layer 4, allowing those routers to filter traffic based on IP address or port number. On the other hand, the FP4 has the ability to filter traffic based on the entire packet header and the data. This is allowing us to filter traffic based on the signature found within the data payload itself. And this is a critical feature for enabling us to mitigate volumetric DDoS attack. And I am now going to walk you through a demonstration of the Nokia Deepfield and FP4 DDoS mitigation solution. We have three main elements in this demonstration. The first one is the FP4 router acting as an IP edge. The second one is Deepfield for identifying the attack and programming the filtering rule in the router. And the third one is an XDR traffic generator sending a volumetric attack to a given target. And I will now walk you through the steps of a manual mitigation so you can better understand the entire workflow. But another option will be to automate that entire mitigation. So the first thing to do is to identify the attack and its pattern. So from the Deepfield user interface, we can see that the XDR traffic has generated an alert, and we have an ongoing incident for a given customer. Currently, we can see that this is a 9.6 gigabit attack, and when clicking on the incident, we immediately have additional detail. So we can see it is a multi-vector attack composed of TCP SYN and NTP. So this is most likely an NTP reflection attack combined with a TCP SYN flood. We also have bit per second and packets per second for each of the components of this attack, as well as top countries and origin ASN. So in this case, we can see that most of the traffic is originated from outside Europe. And when looking at the source IP addresses participating in this attack, we have a similar level of information with, again, countries, origin ASN, as well as some additional lookup information for those IP addresses. And this is provided and updated inside the Deepfield using our Cloud Genome technology. But in addition to this, we can also identify if the source IP addresses participating into the attack are trusted or untrusted, and then, more specifically, identifying if those source IP addresses are coming from known OpenNTP resolvers. In this case, all of the attack traffic is coming from known OpenNTP resolvers. So now that we have this information, we also have traffic samples sent from the router to Deepfield. And this is a critical piece in the entire mitigation. This is allowing Deepfield to identify the common pattern within the attack traffic. So in this case, when opening samples of this attack traffic, we can identify that the common pattern within the NTP data is the hexadecimal string 0xFF01 found at the beginning of the data payload. So we now have identified the attack. We can mitigate the attack by programming a filtering rule in the router. First thing that we are going to do is creating an IP prefix list for all of the NTP open reflector IP addresses participating into this attack. So we're creating this prefix list, giving it a name, and from the Deepfield user interface, with a single click, we can select all of those NTP open resolvers. So we now have this list created. We can save this list and commit to configuration. And now we can use this prefix list into a filter policy that will be installed in the router. So we're creating a new filter policy for NTP reflector filter. And we are going to deploy that filter policy in the 7750 FP4 router. So in this case, the name of the router is the 7750 SRS FP4. This is an IPv4 mitigation, so we're only selecting IPv4. And we are selecting the IP prefix list that was created in step just before. Because this is an NTP reflection attack, this is UDP traffic, so it is IP protocol 17, so we're selecting this. And the last match criteria is the pattern match that was identified using the packet samples. So it is the hexadecimal string 0xFF01 that was identified before as a mask, and as a mask we use 0xFFFF. So we can now save this configuration and deploy this configuration in the router. So here we see that we have two mitigation, one for the NTP part of the attack and one for the TCP SYNFLOT part of the attack. And the last step for the entire workflow is to identify if the filter is dropping the attack traffic. So this is the assurance part. So from the Deepfield user interface, we can now visualize that all of the attack traffic is being dropped and none of the other flows participating into the attack are going through the router. Going back to the main interface now, we see that we have two mitigations and all of the attack traffic is being dropped. The last part is to log in into the router and visualize the filter policy that was sent from Deepfield to the router. So we are now on the router, and we can see that the filter policy that was deployed includes a single entry. This entry is matching the IP prefix list for the NTP reflector IP addresses, the UDP port 123. It is a rate limit policy to 0 kilobit per second, essentially dropping all of the attack traffic, and it is matching the hexadecimal string 0xFF01 that was identified using the traffic samples. The last part is to visualize the packet match and byte match, as well as packet drop and byte drops for each of the filter entry in this filter policy. And this is essentially what is used by Deepfield to report the filtering efficacy. And this concludes the FP4 Deepfield DDoS mitigation demonstration. Thank you.